Networking is learning the language of systems. Welcome! Today, I want to talk about a certification that appears again and again in cybersecurity discussions, the CCNA. And I think people often misunderstand why it's so respected, because the value of the CCNA is not really the certification itself, and it's not in memorizing commands. The real value is in learning how systems communicate. The phrase sounds simple, until you stop and think about it. What does it actually mean for systems to communicate? Imagine sitting at your computer. You open a browser, you press enter. What happens? Your computer does not magically reach the internet. Instead, it begins a journey. Your computer communicates with a switch. The switch learns who is connected and helps to move information where it needs to go. The switch forwards traffic toward a router. The router makes a different decision. It asks, where should this information go? Which path should it take? Then traffic reaches a firewall. The firewall evaluates, should this communication be allowed? Does it match policy? Does anything appear unusual? If approved, the request leaves your environment. It moves across infrastructure, across providers, across networks. Eventually, it reaches another system. That system processes the request and responds, and the conversation begins again in reverse. All of this usually happens in fractions of a second, and eventually, you discover something that changes the way that you think. The OSI model. And for many people, this is where networking starts becoming beautiful. Because the OSI model is not simply 7 layers to memorize. It's a way of organizing communication, a way of asking, what problem is being solved here? At one layer, signals move. At another, systems identify destinations. At another, conversations are created. At another, meaning is interpreted. Each layer solves a different problem. Together, they create communication. And suddenly, technology stops looking chaotic, because now you have a map. Not a map of geography, a map of responsibility. When something fails, you can begin asking, is this a physical problem? A path problem? A communication problem? A translation problem? An application problem? The OSI model gives structure to investigation, and once you learn it, you begin to see it everywhere. Cloud, identity, detection, telemetry, incident response, threat hunting. You stop asking, what is broken? And begin asking, at what layer is understanding breaking down? And this is where I think people sometimes misunderstand networking. People often focus on memorizing commands, but commands are not the point. Commands are language. The real question is, what are we trying to accomplish? Are we trying to allow communication, limit communication, create boundaries, direct traffic, reduce congestion, increase reliability, observe behavior? The commands are simply how we express those decisions. There are concepts in networking that can feel difficult at first, but then become incredibly meaningful later. Subnetting is a great example. At first, it can feel like endless math. Binary, masks, IP addresses, CIDR notation. But eventually, you realize subnetting is not really about memorizing numbers. Subnetting is asking, how do we divide environments? Who should communicate? Who should not? How large should groups be? Where should boundaries exist? An IP address stops being a random number. It becomes a location, context, identity. You stop seeing 192.168.1.0/24 and begin seeing a neighborhood, a boundary, a place where systems belong. And suddenly, the math becomes meaningful. This matters because cybersecurity exists inside communication. Authentication is communication. Authorization is communication. Cloud is communication. Detection is communication. Telemetry is communication. Incident response is understanding communication that went wrong. If communication breaks, systems fail. If communication is abused, attacks emerge. If communication is observable, defense becomes possible. This is why the CCNA becomes so valuable. Not because of commands, not because of memorization, but because for many people, it's the first time technology stops feeling like magic and starts feeling understandable. You stop seeing devices and begin seeing conversations. You stop seeing commands and begin seeing intent. You stop seeing networks and begin understanding how systems organize communication. Because networking is learning the language of systems.